A fireball streaking across the sky, bigger than mountains, capable of wiping out entire civilizations in seconds. Now imagine two apocalyptic scenarios separated by 66 million years. On one side, the Chicxulub asteroid, the space rock that wiped out the dinosaurs. On the other, 3I Atlas, a newly discovered interstellar comet coming from outside our solar system, with the potential to change everything we know. The question no one wants to ask, but everyone thinks about. What if they collided with Earth today? What would change? Would we be able to survive where the dinosaurs failed? Or would we be equally doomed, just with smartphones in our hands while the sky collapses? This isn't a cold scientific comparison. It's a face-off between two cosmic titans, each carrying its own style of destruction. One has already proven its power. The other is an unknown from the depths of interstellar space. Let's unravel, step by step, how each of them would rewrite the history of life on Earth, and why the answer isn't as simple as it seems. But before we imagine the chaos, we need to go back to the beginning. Who are these cosmic monsters? Where did they come from? And why, after all, should we care? The Chicxulub asteroid didn't ask to be famous. 66 million years ago, it was just another chunk of rock wandering the asteroid belt between Mars and Jupiter. It probably spent eons floating in silence, orbiting the sun without causing any trouble. But then something changed. A collision, a gravitational nudge from Jupiter, some cosmic shove, and its orbit was altered. Suddenly, it was on a collision course with Earth. When it entered the atmosphere, it was between 10 and 15 kilometers across. Think about that. The size of Mount Everest traveling at 20 kilometers per second, faster than any bullet, faster than sound can keep up. It didn't fall in Mexico. It exploded on the Yucatan Peninsula with the force of 100 million megatons. Billions of atomic bombs detonated simultaneously. The crater it left is 180 kilometers wide and can still be detected today, half buried under layers of rock and ocean. That impact wasn't a one-off event. It was the trigger for a cascade of catastrophes: kilometer-high tsunamis, global wildfires, a nuclear winter that lasted for years. Temperatures plunged, photosynthesis stopped, food webs collapsed. The result? Mass extinction. 75% of all species, including non-avian dinosaurs, were wiped off the map. Now, on the other side of the ring, 3I Atlas. Discovered in 2024, this object is radically different. It wasn't born here. It came from outside the solar system, an interstellar traveler ejected from some distant star system, possibly millions of years ago. While Chicxulub was rocky and compact, Atlas is a comet, a giant ball of ice, dust, and organic compounds. Its exact dimensions are still debated, but preliminary estimates suggest a nucleus between 5 and 10 kilometers in diameter, smaller than Chicxulub, but don't underestimate it. Comets are unpredictable. They outgas, fragment, change trajectory. And because it comes from outside, its speed could be absurdly higher, potentially 50 to 70 km/h as it crosses the solar system. That means more kinetic energy in a smaller package. The initial conflict is set: raw mass versus extreme speed. Dense rock versus volatile ice, a proven killer versus an unknown threat. Both have the potential to rewrite the biosphere, but in very different ways. Let's start laying out the scenarios. The goal here is simple. Understand what would happen if each of these objects hit Earth today under current conditions. The obstacle? Physics doesn't forgive, and the variables are vast. Entry angle, speed, composition, impact point. Every detail changes everything. Scenario 1. Chicxulub strikes again. Imagine the Chicxulub asteroid, or an identical twin, colliding with Earth right in the Pacific Ocean. The impact instantly vaporizes trillions of tons of water. A column of superheated steam and molten rock rises into the stratosphere. 11+ magnitude earthquakes, yes, beyond the current scale, shake the entire planet. Hundreds of meters high tsunamis sweep coastlines on every continent within hours. But the worst comes after. Dust and soot particles block the sun for months, maybe years. Global temperatures drop 10 to 15 degrees. Crops fail. Supply chains collapse. Solar energy, our bet for the future, becomes useless. Billions of people face famine as governments fight over ever scarcer resources. Sure, we have technology now. Nuclear bunkers, strategic reserves, hydroponic agriculture. A fraction of humanity could survive. But it would be brutal survival, perhaps regressing by centuries. Industrial civilization? Probably over. Scenario 2. 3I Atlas enters the scene. Now, the interstellar comet. Because it's smaller, you might think it's less dangerous. Fatal mistake. Remember, it travels at 50+ km/s, almost 3 times Chicxulub's speed. Kinetic energy is mass times velocity squared. Do the math. Atlas could release energy comparable to or even greater than the original asteroid, depending on the angle. But there's a twist. Comets are fragile. There's a real chance Atlas would fragment upon entering the atmosphere, especially if it came in at a shallow angle. That could be good. Energy dispersed into multiple smaller impacts, or catastrophically worse. A rain of fragments devastating entire continents, like a cosmic machine gun. And there's more. Comets carry volatile compounds: methane, ammonia, cyanide. An impact could release global toxic clouds, poisoning the atmosphere and oceans in ways Chicxulub never did. It would be chemical extinction on top of physical extinction. Here's where the comparison gets wild. Let's scale the specific obstacles each impact would create for human civilization, and the decisions, or lack thereof, that would determine our fate. Chicxulub 2.0. The known killer. The good news? Rocky asteroids are trackable. Programs like NASA's Planetary Defense coordinate global telescopes to map near-Earth objects. If a modern Chicxulub were detected 10-20 years in advance, we'd have options. Deflection missions. Probes like DART, which proved it works in 2022, could alter the trajectory by millimeters, enough to turn a direct hit into a near miss. Nuclear explosions, not to destroy it, impossible, but to gently push it with asymmetric radiation. But there's dramatic irony here. Most governments still underestimate the risk. Budgets for planetary defense are ridiculous compared to military spending. And if the warning came with only 5 years, 1 year, the story changes completely. Suddenly, our decisions become just panic. Atlas, the interstellar unknown. Now the real nightmare. Interstellar objects travel so fast they may not be detected until they're almost here. Oumuamua, 2017, and Borisov, 2019, the only confirmed interstellar objects before Atlas, were discovered after they had already passed perihelion, closest point to the Sun. In other words, we saw their backs. If Atlas decided to hit us, we might have weeks or months of warning, not years. Deflection? Forget it. There's no time to build and launch missions. Mass evacuation of an entire planet? To where? The only strategy would be acceptance and local preparation. Deep bunkers, seed preservation, like the Svalbard Global Seed Vault, genetic banks. Basically, betting on the survival of small human colonies and trying to rebuild afterward. A cruel red herring. All those safety infrastructures exist, but they were designed with nuclear wars in mind, not interstellar comets. Would they be enough? Probably not. Here we explore a disturbing paradox. Extreme crises can generate extreme opportunities, but for whom? And at what cost? Microscale, individuals and communities. In both scenarios, the initial chaos favors those who are prepared. But prepared for dinosaur-level extinction? We're talking about radical prepping. Owners of luxury private bunkers, yes, that exists, look at Vivos Europa or Survival Condo, would have an initial edge. But for how long? Seeds run out, systems fail, and when you emerge, you find… what? Scarcity management. Nations with massive strategic reserves, Norway, Switzerland, the US, would have a few more months. Countries dependent on imports collapse in weeks. Macro scale, geopolitics and power. Here's the paradoxical scaling. The impact would level nations, but only temporarily. Afterward, old hierarchies would reassert themselves, or new ones would emerge. Chicxulub 2.0. A Pacific impact would devastate East Asia, including China, Japan, both Koreas. Europe and the Americas would face secondary tsunamis, but less direct hits. The result? The global balance of power would be permanently rewritten. Whoever controls what's left, oil, coal, fresh water, becomes the hegemon of the post-impact world. 3I Atlas. Fragmentation of the comet could spread destruction more democratically. Multiple impacts, multiple continents. That levels the field, but also means no one has an advantage. The result wouldn't be a post-apocalyptic empire, but tribalization, small enclaves fighting to survive, without global coordination. There's a critical variable we haven't explored yet. What do we do before impact? Here comes the technological foreshadowing, signs that humanity, despite being fragile, has some cards up its sleeve. Planetary defense, fiction or reality? The DART, Double Asteroid Redirection Test, mission in 2022 was historic. A car-sized spacecraft slammed into the asteroid Dimorphos and changed its orbit. Proof of concept validated, but Dimorphos was 160 meters, microscopic compared to Chicxulub or Atlas. Planting. If we invested globally in planetary defense, say 1% of the world's GDP per decade, we could build early warning network, dedicated space telescopes covering the entire sky 24/7, interceptor fleet, probes on standby, ready for rapid launch. Purpose-built nuclear devices, not for war, but for emergency deflection, cleaner bombs designed to push, not fragment. Payoff. With 10-20 years of warning, a modern Chicxulub could be averted. Not easy, but possible. The cost would be astronomical, trillions of dollars. But compared to extinction, a bargain. The Atlas problem. But here's the counter-genre. All that tech presumes time. Atlas, coming from interstellar space, could appear without useful warning. No current technology changes that. The solution? Vertical integration of survival. Not just protecting the planet from impact, but ensuring civilization survives the subsequent nuclear winter. Large-scale underground agriculture, protected hydroponic farms, powered by nuclear or geothermal energy. Digital and biological archiving. DNA of all species, complete human knowledge, stored in multiple geologically stable locations. Off-world colonies, Mars, the Moon, orbital habitats. If Earth is hit, humanity continues. Somewhere else. That sounds like science fiction, but the planting is there. Elon Musk and SpaceX explicitly cite civilization backup as a motivation for colonizing Mars. The real reason? Maybe we'll learn decades later whether it was paranoia or prudence. Here the narrative turns into meta-critique. We need to judge our own scenarios. What's possible, what's fantasy, and what science actually says. And the scientific verdict, NASA, USA, space agencies. Chicxulub-scale impacts are rare, intervals of 100 million years, statistical probability of 1 in the next century, 0.000%. But smaller objects, 50, 100 millimeters, that would still cause regional devastation, we find new ones every week. Astronomers, academic community. 3I Atlas specifically poses no threat to Earth. Its orbit doesn't cross ours. But the discovery proves interstellar objects exist and are more common than we thought. The next one may not be so harmless. Media pop culture. Asteroids sell headlines. Doomsday asteroid gets clicks. But sensationalism obscures the real work of cataloging and mitigation. Here's the brutal truth the public often ignores. While we debate hypothetical scenarios, astronomers already know of specific asteroids that will pass close to Earth in the coming decades. Apophis, 2029, Bennu, 2182. None are going to hit us, probably. But the probably is calculated with precise orbits. An interstellar object doesn't give that courtesy. It's a sniper's bullet you only see after it's been fired. Systematic revelation. Fact. Chicxulub released 100 million megatons. A similar impact today would kill Tanbontu or 90% of the human population in the first 5 years. Famine, cold, disease. Fact. Interstellar comets travel 2 to 3 faster than solar system objects. Energy isn't just size, it's velocity squared. Fact. Humanity spends $200 million a year on planetary defense. Comparison. The movie Armageddon, 1998, cost $140 million. Fiction costs almost as much as real protection. So, are we safe? The short answer, it depends. On investment, on luck, on warning time. In the long run, another impact is a statistical certainty. The question isn't if, but when, and whether we'll be ready. Could what looked like a threat be a disguised opportunity? Paradox 1. The threat that unifies Chicxulub exterminated dinosaurs, but opened ecological space for mammals. Without it, humans would never have existed. Likewise, the threat of a modern impact has already generated international cooperation. NASA, ESA, JAXA, Roscosmos collaborate on planetary defense. Technological advances, probe propulsion, detection of distant objects, existential awareness. We're fragile, we need a backup. Payoff. The fear of apocalypse can be the catalyst that forces us to evolve, not biologically, but technologically and socially. Paradox 2. Enrichment through chaos. Comets are rich in water, amino acids, organic compounds. There are theories, panspermia, that life on Earth itself came from comets. 3I Atlas, if it could be captured, not impacted, would be a scientific goldmine, direct evidence of chemistry from another star system. Reversal. The villain becomes a resource. Future asteroid mining projects, companies like Planetary Resources, before it failed, tried this. Think this way. Dangerous objects are also reservoirs of rare materials. We'll leave the viewer with this. Are these objects enemies or teachers? Chicxulub taught us about extinctions. Atlas teaches us about cosmic unpredictability. Maybe the real lesson is, the universe isn't malevolent, it's indifferent. And in that indifference, we're forced to take care of ourselves. Chicxulub was pure chaos. No moral, no villain, just brutal physics. But from its destruction came our origin. We are children of the impact, literally. Every carbon atom in our bodies passed through stars, supernovas, and maybe even comets. We are cosmic dust that learned to think. 3I Atlas, on the other hand, is a reminder. The cosmos is bigger than our solar backyard. There are forces out there we don't know, trajectories we don't foresee. Humility is necessary. Transformation arc. We started with fear. What if we go extinct like the dinosaurs? We end with agency. But the dinosaurs didn't have telescopes, computers, rockets. We do. The difference is us. Final polyphony. Carl Sagan, astronomer, 1994. The extinction of the dinosaurs was a tragedy, but it was also an avoidable accident. We have the technology to avoid the next one. The question is, will we have the will? Neil deGrasse Tyson, astrophysicist, 2023. Asteroids are nature reminding us that the final exam in the course of spacefaring civilization isn't multiple choice. It's pass-fail, and studying is optional, but the test isn't. Anonymous critic, Reddit, 2025. We spend trillions on weapons to kill each other, but millions to save us from space rocks? Priorities are a bit off, aren't they? The truth is, we don't know if a Chicxulub 2.0 or a real Atlas will come in our time. But we know the probability isn't zero. And we know every generation faces its own asteroid, climate change, pandemics, conflicts. The question is always the same. Are we going to look up or pretend the sky doesn't matter? If this video made you think, if it made you look at the sky differently, even for a second, mission accomplished. The universe is vast, indifferent, and sometimes violent. But it's also fascinating. And being alive to witness it? That's a privilege even the dinosaurs didn't have. Subscribe to the channel for more cosmic face-offs. Until the next video, keep your eyes on the sky and your feet planted firmly on Earth.